Architecture. So the platform architecture, if I talk about 9508, so it has a 8 line cards, right? It has a 2 supervisor engines, right? It has a 10 power supply, right? And so it is a front view, right? If I talk about the rear view, this is a fan, right? This is your fabric module. So in the Nexus 7K we have a 5 fabric module. Here we have a 6 fabric module. So there are 6 in numbers, right? And this is called as redundant system controller cards, right? So you have a dedicated line card, supervisor engine, 2 power supply. You have a total number. You can do a 10, but I will let you know what is the and a 6 fabric module, 3 fan tray, and a system controller. So these are the component which makes a Nexus 9500 a modular chassis. And this power supply you can configure it N plus 1 redundancy, N plus N redundancy, like that. What we learned in the Nexus 7K. Go through it.
In the 7K and 5K architecture, we were using 7K as a core layer and 5K as the aggregation layer or distributed layer.
Yeah.
Here in 9000 series, both 9000 itself will be performing one is core layer, another one is
distribution layer.
Distribution layer. So for completely will be of 9000 series only. We cannot mix. Yes. And
no. See what is the architecture? You know, the architecture. If I talk about ACI, because Nexus 9K is basically used in ACI mode, right? And in the ACI mode, what happens? You have a spine engine, spine switch, right? So it can be Nexus 8 or 9, 950, 16 or 9504 model, right? And here you have a leaf switches, and the leaf switches can be of 95K or 93K, right? And these leaf switches are connected to your spines, and this is of 40 gig. So this is it doesn't have anything you need to configure. It is simply a backbone of your network, right? And the Nexus, and this is what we call it spine, right? And we call it it is a leaf. This leaf is a distribution layer switch. So, and how to configure the routing switching? For the routing and switching, you have a Epic server. It is just a UCS series server. Cisco provides it, and you a connectivity like this one, right? You have a GUI. Once you do the basic configuration, you will be opening a GUI on your laptop, and through the laptop you will be configuring all your routing, switching, layer 2, port channel, wheel, and everything. It will push here. So you don't need to log into the Nexus 5K or a leaf switch via configuration CLI mode, and you have to do everything, right? So it is a GUI based. So right, and once all your policies will be configured, and then here you can connect 5K, 7K, or 5K, or 2K, or something, anything, or a 3750, anything, and you provide the connectivity, and from the down you can connect a switch, your servers, everything. So all your servers traffic will go from here to Nexus 5K leaf switch. From the leaf switch, because you have a backbone, so it will go to the backbone, right? From the backbone it will return back, and then your routing and switching will be performed. If you have connected a WAN here, so it will go to WAN. If you have if you want to send anywhere inside the data center, it will go inside that data center. So in the ACI mode, you have a spine which act as a backbone. You have a leaf switches. Leaf switches is just like a distribution switches. Now, when I talk about the spine switches can be of 9504 modular switch, 9508 modular switch, 95016 modular switch. So if we are using a Nexus as a spine switch, so the line card should be ACI enabled, right? And and that line card should will have ACI ASC chip, ACI spine engine on that line cards here. And if you are using a leaf switch, then your line cards ASIC will be ALE, ACI leaf engine. So it will be used as a leaf, and that will be used as a spine. Understood?
Yeah, look.
Now, as I already said that it doesn't have a mid plane. Mid planes means there is something like that, right? So from front end you connect the line card, from the back end you connect the fabric module. It will be adjusted like same way, right? So the mid plane is designed for power and cooling efficiency, designed for the reliability, designed for the future scale. Future scale means if it is upgraded, if you have a 40 gig line card and if you want to you want to replace your 40 gig line card to 100 gig line card, you can easily do. So just replace 40 gig line card, connect the 100 gig line card, it will be adjusted in the backend, right? So it has no pre-designed backplane. It can be simply upgraded. So you can see that there is no simply backplane. It is just like a empty module. You can see from front end to back end, both side. It is visible. So from the front you insert the line cards, from the back you insert your fan tray and the fabric module. It will be adjusted like anywhere. There are two types of supervisor modules: supervisor A and supervisor B, right? So if I specifically talk about the supervisor module, so so it has a processor, 1.8 gig and 4 core. System memory, it has 16 GB. It can be upgraded to 48 GB. It has one serial port. It has a one management port. It has a two USB upgrade, and it has a SSD storage 64 GB. So this is how your supervisor looks. It's very small in size, right? So if I talk about the models of the supervisor, you have a supervisor A and supervisor B, right? Supervisor A has a 4 core and 1.8 gigahertz. It has a 6 core. It has 2.2 gigahertz, right? It is having 16 GB memory. It has a 24 GB memory. It has a SSD storage 64 GB. It has a SSD storage 256 GB. So, but if I talk about the Nexus 7K, what we have a dual core. We have a one core, and we have a 2 quad core in SOUP 1 and in SOUP 2 and in SOUP 2E. Right, here we have 8 GB, here we have 12 GB, here we have 32 GB. But see, here we have 16 GB memory, 24 GB memory, and SSD storage 64 GB and 256 GB. So if you compare this, your Nexus 9K is much more having memory capacity, and you have a 4 core and 6 core, right? Supervisor CPU. So these are the two supervisor modules we talk about in Nexus 9500. Now, see, why does the supervisor engines are used or a CPU are used, right? So CPU are used, to handle your management traffic, your protocol traffic, your all other traffics. SNMP, TechX, routing protocol traffic, switching protocol traffic, everything. Not every data traffic go to the CPU. Why? Because your layer 2 forwarding engine and layer 3 forwarding engine are just copied to locally to your line cards. So if every traffic comes to the line cards, it has a locally layer 2 and layer 3 routing and switching engine. It verifies its routing and switching part, and it forwards the traffic. So not every traffic go to the supervisor module. But in Nexus 9K, what the system has designed that even though your management traffic, your routing protocol traffic, switching traffic like BPDU, SNMP, TechX, and TP traffic, all these traffic go to the supervisor. But in the Nexus 9K, it has designed in a such a way that the idea of Nexus 9K was, to reduce the CPU offload. So they produces the another, module we call as a system controller module, right? So system controller module is another module which is inserted in the backside of the your chassis. What it does, see here, when a packet is not processed by the line card, it is sent to the fabric module and a CPU for processing, which can sometimes cause bottleneck for offloading work, right? These are the similar as supervisor with half width. All the management packet which were earlier sent to CPU is sent to system controller, right? So earlier what is used to do, we used to happen, earlier all the management traffic were sent to the supervisor or a CPU for processing. But what Nexus 9K did, Nexus 9K brought a system controller module, and what it does, it takes all the management traffic which were earlier sent to CPU for processing. Now the system controller module will process it. So it offloaded the CPU, burden. So what type of traffic it, offload? It provides the management traffic sent to CPU for system controller. It also provides the, EOBC for control plane communication, device management, right? So EOBC means Ethernet out of band channel, right? And what does it? It helps, all the device management traffic which was also sent to the CPU earlier. Now it will handle, right? And it has also provision for EPC. EPC means Ethernet Protocol Channel Switch. So all the protocol related packets it will also handle. So it it can handle management traffic, right? It can handle device management traffic, and it handles protocol packet also. Earlier, these all traffic were sent to CPU, but now in the place of CPU, this system controller handles it. So it offloaded the CPU working. So now your CPU will be more free than it used to be, and it can, process more packet. It can, provide more powerful support to your device. So this helps lot of offloading CPU cycle to the system controller, which helps to achieve high system performance. So you have reduced your CPU working and you have offloaded it to system controller. And what type of traffic you have offloaded? Management traffic, device management traffic, and protocol traffic. These all traffic will be now sent to system controller, and your CPU will be free, and through which you can achieve a high system processing. Understood? Write it down if you want. Nexus power supply 9500. In the Nexus 9500, we have a power supply which looks like this one. It has each power supply will have a 3000 watt in AC supply, right? And it provides a 90 up to 92% of efficiency, right? It has a 92% efficiency, right? It can provide, you can how the PS configuration you can do. You can go for minimum one power supply, two power supply for fully loaded chassis, and plus one redundancy, and plus one grid redundancy, right? So you have a total of 10 power supply slots in your chassis, right? Out of 10 power supply, minimum two is required, right, to start your chassis, and four is max. You can use four, right? But you have a slot of 10 power supply chassis slots. You can insert 10 power supply, no problem on that. And the Nexus 9500 can support only a AC power supply. DC power supply is still under development, and the max capacity of power supply is 10 to accommodate full powerful future powerful line cards. So in the future, maybe Cisco has a plan to introduce a more powerful line cards. So it has given a provision to have a 10 power supply slots, so that if you use that powerful line cards, then your system needs a more power supply, so you can use 4 10 power supply. But to start with the fully loaded chassis, you need minimum 2 power supply to start with, right? If I talk a fan tray, this looks like a fan tray. It is used in the Nexus 9500. There is a 3 dual fan tray, right? And it's a dynamic speed control driven by temperature sensors. It has a sensors on it. So as soon as your system got heat up, the speed of the fan tray goes increasing, and likewise it goes down, right? You have an n plus one redundant fan tray. You can configure for that. And the fabric module, which we talk about in the Nexus 9700, the fabric module is called as a backplane. So it in the Nexus 7K we used to have a 5 fabric module, but in the Nexus 9K we have a 6 fabric module, and it also has. But see, the difference is between Nexus 9K and 7K fabric module, that Nexus 7K module doesn't have any CPU, but in the Nexus 9K fabric module you have a CPU of a quad core CPU of 1.3 gigahertz. Why? It also reduce the supervisor offload. So there may be some traffic which is sent to the fabric module, and that needs to be processed, which so the Cisco has also provided a small CPU of 1.3 gigahertz in the fabric modules also, so to reduce much more supervisor offload. So the supervisor offloading can be done via system controller, which we talked earlier, and the fabric module, which also has a CPU. So it doesn't have a much capability, but yes, it can reduce some of the CPU offload, right? The fan tray, if I talk about the fan tray, the fan tray as this is your fan tray, right? So the fan tray are installed after the fabric module. To service the fabric module, first what you will do, you will remove the fan tray. First you will remove the fan tray, and then you will take out the fabric module, and then you will replace it, and then you have to insert it. So if one fan tray is removed, the other two fan tray will speed up to 100% to compensate for loss of cooling power. The temperature sensors in the chassis will be shut down components once max temperature is reached. So it has a sensor installed in the fan tray, and if you remove one of the fan tray, then other two fan tray will speed up to 100% to compensate for that one fan tray.